Hey everybody, welcome back. This is M021 at College of the Sequoias. It's Introduction to Statistics. And we're going to continue exploring probability. It's chapter 5 for us. And we covered basic probability in section 5.1. And now we start looking at what happens if we're talking about the odds of different events happening. So 5.2 is on the addition rule and complements. So let's talk Monopoly. Most people have played Monopoly at some point. So we'll use that. To explore this idea. And I don't know about you guys, but most families, most households have some house rules, a common house rule that people have. This is not part of the official rules, but a common house rule is all taxes and fees get put into free parking from like chance or community cards. Gets put under free parking and if you land on free parking, you collect all the money like it's the raffle. And free parking rewards you with all the current cash, all the current savings. Okay. So you're on the 2nd Street of Monopoly. You know, the street with St. Charles and St. James and oh gosh, what are the other ones? The electric, no, water, no, electric companies there. We got some other ones. And let's say this is what you want. This is our scenario. You want to roll an 8 to land on free parking. Let's say there's a lot of money underneath there, like $5,000 or something. That's a lot of money, Monopoly. You want to roll an 8 to land on free parking or roll doubles so you can go again. If you roll below an 8 and roll doubles, you might get to go again and hit it on your second roll. Or if you rolled above 8, like you rolled a 12, it gets you, you can roll again and start getting around the track faster to get to it. So what are favorable outcomes? Let's list the favorable outcomes. Favorable outcomes. And let's do it by category. So let's pause that for a second. Let her write that down and explore it. All right. So remember, we want 8s or doubles. Roll an 8. We'll put in column 1. Or roll doubles will be column 2. And I'm just drawing rectangles. These are going to be basically my 2 dice. These are not dominoes. These are both dice, and they're just put next to each other. So I could roll a 2 and a 6, and that would give me 8. I could roll a 3 and a 5, and that could give me 8. And let's say the first die is a red die and the second die is a blue die. That way, because which die is which matters. I could get a 4 on the red die and a 4 on the blue die, and that gives me an 8. And I could get 5 on the red die and 3 on the blue die. Switch the numbers around for the colors. That gets 8. Same thing with 6 and 2. 6 on the red, 2 on the blue. That'll give me an 8. So it looks like there's 5 outcomes here. And if we look at doubles, again, red in the left column, blue there. There's 6 combinations. The dice have to match. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. 6 outcomes. So the probability of rolling an 8, it's handy to know. There are 36 possible outcomes. If you look at all combinations of 2 dice listed, we'll discuss why that works in 5.3, where we come up with 36. Rather than counting them, how we can get at it with the other form. So we got 36 possible outcomes. The probability of an 8, that the roll equals 8, is 5 outcomes out of 36. The probability that the roll equals doubles is 6 out of 36. I'm not going to simplify. And what's the probability of either? Probability that the roll equals 8 or doubles. Well, it's still going to be out of 36 outcomes. Let's count our outcomes though. We do not want to duplicate any outcomes. So all of these are unique. 1, 2, 3, 4, 5. All the 8s are unique. And then I'm going to go down the doubles list. And if it appears on the roll an 8 list, I'm not going to count it. Otherwise, I will. The 1 and 1 does not add up to 8. It doesn't show up on the 8s list. That'll be roll 6 that works. 2 and 2 is the 7th outcome that works. 3 and 3 is the 8th outcome that works. 4 and 4 actually already showed up on the doubles list, so it does not work. No, we're not going to count that one. We already did. Can't count it twice. 5 and 5 adds up to 10. That's not on the 8 list. And 6 and 6 is not on the, it adds up to 12. That's not on the 8 list. So that's 10. 10 out of 36. I'm ignoring simplifying. When you're doing math or doing the homework, and any time in reality, you should simplify. So this would be 5 over 18, and that would be 1 over 6. Now, why is it that I can't just add these and get that? So pause this, and I'm going to leave that at the top right there so that we can reference it real quick. We can't just add the probability of rolling an 8 and the probability of rolling doubles. If I do that, probability 8 or probability of D is 5 over 36 plus 6 over 36, which is, we add numerators, keep the denominators the same. It's 36 on bottom, 5 plus 6 on top, gives me 11 over 36. So we can't just add the two things. How far apart is 11 over 36 and 10 over 36? This is apparently one outcome too many. If we took 11 over 36 and subtracted 1 over 36, we'd get the 10 over 36 that we got from our counting. That's the probability of rolling an 8 or doubles. Okay? Where does this 1 over 36 come from? The overlap. Our overlap. Remember, on probability, the bottom is the total outcomes, and the numerator is the outcomes in event, number of outcomes in event. So then when I say overlap, this is the probability of both. It's the probability that the roll equals an 8 and doubles. That's both, or both. This leads us to our general equation. The general addition rule for probability for two events E and F, the probability of E or F equals the probability of event E plus the probability of event F minus the probability of E and F, both. That's the general formula. How did that match up with ours? The probability of an 8 or doubles equals the probability of 8 plus the probability of doubles minus the probability of 8 and doubles, which is 5 over 36 plus 6 over 36 minus 1 over 36 equals 10 over 36. Okay? Okay, let's take it a step further. Let's change the scenario. Let's say you're exactly 3 spaces away from free parking. Well, it's going to be similar to this, but let's do another scenario. Scenario 2, we're only 3 spaces away. We are 3 spaces away from free parking. So we want a 3 or doubles to go around again. DBL is going to be my abbreviation for doubles. I used it earlier. I didn't actually specify it. So we already listed the categories for doubles. but I'll relist them here. 1, 1, 2, 2, 3, 3. We could have 4, 4, 5, 5, or 6, 6. To roll a 3, I either need a 2 and a 1 or a 1 and a 2. So the doubles have 6 outcomes still. Rolling a 3 is 2 outcomes. And if let's look at our formula. I'll write it down again in general. Probability of E or F equals probability of E plus the probability of F minus the probability of both. So we want the probability of a 3 or doubles equals the probability of a 3 plus the probability of doubles minus the probability of 3 and doubles. The roll has to be both. Well, the number of outcomes hasn't changed. It's still 36 in the denominator for all of them. The number of outcomes that gave us a 3, there's only 2 outcomes. And there was still 6 outcomes there. The number of overlaps, do these overlap at all? No, there's no overlaps. 3 is an odd number, and doubles all add up to even numbers. So it's not a doubles. And we can see there's nothing doubled here. The overlap is 0. No overlap. So the probability of 3 or doubles, we really don't even need the last thing, the subtraction, do we? This is just the probability of 3 plus the probability of doubles. There is no overlap. 2 over 36 plus 6 over 36 equals 8 over 36. And those are both divisible by 9 or 4. We could simplify this to 2 over 9. So let's talk about what's different here versus the first scenario. For the addition formula, for the addition rule, we subtract out anything that might be double counted in both categories. One event for any event that is counted in both categories or appears in both categories. That's what I call the overlap. Showed up in both categories. So for 8s and doubles, four and 4 showed up in both categories. By using the probability or the addition formula, using the addition formula or addition rule, we counted that outcome twice, once in each category. So we have to subtract out the second count. Let's say the extra count. Okay. When there is no overlap, or there's no event appears in both columns, there's nothing to subtract. We call these events, when this happens, these events are said to be disjoint, are called disjoint events. They also say the events are mutually exclusive. And what that really means is there's no common events between the two. No events in common. Every event or every outcome in event E is excluded from event F. Okay? When we have disjoint events, the addition formula simplifies to E or F, probability of E or F equals probability of E plus probability of F. Now, they might have led with that in the lecture or in the book. I don't like leading with the easiest scenario because this one only works if the events are disjoint. And let's specify that. That formula only works if they're disjoint. It's safer to memorize the full rule. The probability of E or F equals the probability of E plus the probability of F minus the probability of E and F, or both. Both events, or both events have a common outcome. Or what both events have in common. Okay, that's the safer rule to remember because sometimes this is 0. For disjoint events, this is 0. And subtracting 0 is easy. Doesn't change it. All right, so that's the addition rule. And I said we were also going to talk about complements. Complements is spelled with no I in it. This is different than like giving someone a compliment, saying that they are clever or physically fit or something like that. That has an I between the L and the M. Here it's COMPLEMENT, the complement rule. And so let's talk about complements. what are complements? Let's go back to our dice thing. The sum of two dice can be odd or even. Okay. Let's use O for odd. And E for even. And that is the only two ways we can add together two dice. So the sum of these two, the probability of rolling an odd sum, probability of O, and if we add that to the probability of rolling an even, or probability of E, those are the only two outcomes, so it should be the total probability. Probability of getting any outcome. That covers all the outcomes. This is the probability of any outcome is 1. They have to add up to 1. So complements are this. When the probability of two events probability of two mutually exclusive or disjoint events adds to 1, we say these are complements. And what we do to do this, we use the letter C in superscript, which is elevated script. And it makes it look like an exponent. So the complement of odd, that's how we write the complement of odd. O with a C written up top high. Complement of odd is even. And the complement of even is odd. Okay. And so if we go back to looking at that equation we had, probability of 0 plus probability of E equals 1, I can actually rewrite that. Probability of 0 plus probability of E. I'm going to replace O with its even complement. The probability of even complement plus the probability of even equals 1. The probability of an event and its complement equals 1. Event or its complement happening is 1. where I tie that into the or part, just like eighths or doubles. The probability of E or E complement, there's no overlap, so it's the probability of E plus the probability of E's complement. That equals 1. That's where the complement rule and the addition rule tie in together. And this is true for all complement relationships. And there's something else I want to touch on in this category. Let's look at another way of writing that. I had the probability of E plus probability of E complement equals 1. If I subtract the probability of E from each side, I get the probability of an event's complement equals 1 minus the probability of an event. This is super duper useful. I'm going to give you a scenario. We don't have all the rules on how to use it yet, but I'm going to give you a scenario where this is helpful. There are 18 girls and 12 boys in a class. If I randomly select 4 people, what is the probability that at least one is a girl? We're going to go into this. This is like 5.4 and 5.5. To answer this question, we need to do 5.4 and 5.5. 5.3 as well. 5.3 covers independent events. And 5.5 is counting rules. The idea here is at least when we see at least one girl, this means the possible, what are the possible events here? If I choose 4 people, I could choose the number of girls. I could choose 0, 1, 2, 3, or 4. The probability of 0 girls, this one right here, literally means all boys. Only boys were selected. Everything else is the complement of all boys. Okay? These are a pain to calculate, even one of them. These are a pain to calculate. As you'll see when we get to it in later sections. But at least one girl is the complement of all boys. Okay? So I could say the probability of all boys plus the probability of at least one girl. Since they're complements, that adds to 1. But I can now solve for that. The probability of at least one girl equals 1 minus the complement of it, at least one's complement, which is 1 minus the probability of all boys. Because remember, the complements things go back and forth. Maybe it's better to write all boys, or at least one girl, the complement of it is all boys. That might be the better way to write that, which matches here. And again, we haven't shown how to come up with those yet. That's in another section. But I can tell you this is relatively easy. And we'll bring up this scenario up again exactly. In fact, I'm going to make a little post-it note to make sure I do this exact event. Do 18 girls, 12 boys, 4 people, and then at least one girl. Make a little post-it note for myself so when I get to that video, I make sure it's in there. It's essential. All right. That's the ideas of this section. We will wrap that up here. Peace.